Okay, well, we're on the topic of finding the discriminant to determine the number and type of solutions. We'll talk about what the discriminant actually is here as we go along here, but I want to start out with this idea. If I give you this quadratic equation to solve, and I say, please find out what x is when y is 0, I'm really asking this question. What numbers would you have to put in for x in order to get 0 for y? Well, if I look at that equation on a graph, oops, let me change that equation back to 8. Okay, if I look at this equation on the graph, um, I'm still asking the same question. What numbers would I put in for x to get a y of 0? And if I start looking along at points here, what would I have to put in for x? Remember, x is the first number to get a 0 for y. And here's one of them right there. Okay, if I put a -4 in, I get a 0 for y. Well, also, if I put a -2 in, I get a 0 for y. So really, when we solve an equation like this for x when y is 0, we're trying to find out where does this graph cross the x-axis. Okay, if this happened to be a 9, then we'd say, well, it only crosses at one place. It looks like it crosses right here at -3. Okay, but what happens if it's a 10? Okay, it never crosses. In other words, there aren't any numbers you could put in for x in order to get 0 for y. So let's see what that looks like when we're solving an equation. If we were to solve this using the quadratic formula, we'd say, okay, look, x is -6 plus or minus the square root of 36 minus 4 times 1 times 8. Okay, all divided by 2. And so we need to figure out what's under the square root sign. That's 36 minus 32, -6 plus or minus 36 minus 32 is 4, and the square root of 4 is 2. So look at this. I get two solutions. One of them is -6 plus 2, which is -4, divided by 2 is -2. And the other one is -6 minus 2, which is -8, divided by -2, which gets us -4. Now, we knew those were the solutions already. Okay, well, I want to look at another equation and do the same kind of thing. So I'm going to grab all this stuff and get it out of the way. Put it over here for a bit. Okay, I want to grab this equation right here. And we're going to do the same thing. We're going to solve for x. And so x equals -6 plus or minus the square root of 36 minus 4 times 1 times 10. Okay, and everything divides by 2, or 2 times a, but a is 1. So now I get -6 plus or minus the square root of 36 minus 40, so -4 over 2. Well, square root of -4 is not a real number. Okay, and as you saw from the graph, oops, if we have plus 10 right here, there aren't any places where you can put a number in for x and get 0 for y. So here we can tell as soon as we get a negative number under the square root sign, we can tell there aren't any real solutions to this. Okay, there's two non-real solutions, but there aren't any real solutions. Well, I want to go on and ask this question. What if we were solving some equation and we ended up, let's say we had -8 plus or minus the square root of 0 over 4? Well, we all know the square root of 0 is 0. So what's -8 plus 0? -8. Divide that by 4, you get -2. What's -8 minus 0? Still -8 divided by 4 is -2. So if we end up with a 0 in here, then we only got one solution. Okay, well, what we're going to do is be able to say, look, just by calculating the part underneath the square root sign, we can figure out what type of solutions they are. So we're going to look at a few more. Let's say I'm solving an equation and I end up with, say, -3 plus or minus the square root of 6, and right in here is a 16. Well, we all know that square root 16 is 4. So you get a whole number when you square root 16 because it's a perfect square. So we're going to end up with two solutions, and they're going to be nice, what we call rational solutions. They're going to be fractions. Okay, so the square root of 16 is 4. So our solutions are negative 3 plus 4, that's 1, divided by 2 is 1/2. The other solution is negative 3 minus 4, that's negative 7, divided by 2 is negative 7/2. So we ended up with two rational solutions. Okay, I'm going to write that, two rational. Okay. Well, let's say we're doing another one here, and this one ends up being 5 plus or minus the square root of, let's say, 0 over 4. We all know that negative 5 plus square root 0 is 0. Okay, and negative 5 minus, I'm sorry, 5 plus the square root of 0 is 5. Divide by 4, you got 5/4. And 5 minus 0 is still 5 divided by 4. So we got one rational solution. Okay, rational again just means you end up with a nice fraction. Okay, well, what happens if we were doing a equation that looks like this, and maybe it's 6 plus or minus the square root of negative 40, okay, over, let's say, 2. Well, we know that the square root of negative 40 is not a real number. So you're going to get 0 real solutions. Okay, you're going to get 2 non-real solutions, or 2 imaginary solutions. So we'll write 2 imaginary solutions. Okay, I should have clarified here. This should be 2 real rational. This is 1 real rational. And then we're going to get 2 imaginary. Well, there's one more case you can get, and that is, what if the thing under the square root sign is positive, but it's not a nice perfect square? So let me put that over here. Suppose I'm doing one and I end up with negative 5 plus or minus the square root of 12 over 2. Okay? Well, square root 12, it's a real number. It doesn't work out to be a nice fraction, so it's not rational, but at least it's a real number. So we end up with 2 real irrational solutions. Okay, so there's 4 different cases we end up with here. There might be 2 real rational solutions if the number under the square root sign is a perfect square. There would be 1 real rational solution if the number under the square root sign is 0. And if the number under the square root sign is a negative number, you get 2 imaginary. Lastly, if the number under the square root sign is positive but not a perfect square, then it ends up being 2 real irrational. So I like to make this table that helps people summarize all this. Okay. The thing under the square root sign is the b squared minus 4ac part, right? Okay, we actually call that the discriminant. Okay, so that's where that word came from at the beginning of this video. The discriminant. It helps you discriminate between different type solutions. Okay, if it's 0, you end up with 1 real rational solution. Okay, so in our table, solution types, solution number and type. Okay, if it's positive, well, let's say let's do negative. If it's negative first, you end up with 2 imaginary solutions. Okay? If it's positive perfect square, okay, you get 2 real rational. Okay, and finally, if it's positive not perfect square, you get 2 real irrational. Okay, so the discriminant gives you a quick way to determine which type of solutions you're going to get. If you were solving one of these equations like launching something up in the air, and we wanted to know how long will it take for this thing to reach a height of 200 feet, well, we would end up solving this equation. We'd set this side equal to 0 by subtracting 200 from each side. Oops. Minus 190. And before we bother solving this thing, let's check and see what the discriminant would be, the b squared minus 4ac part. Well, 14 squared is 196 minus 4 times a, which is negative 16, times negative 190. Okay, well, 4 times negative 16 times negative 190 is going to be a positive number, and it's going to be way bigger than 196. So when I take 196 minus this really big number that's positive, I'm going to get a negative number, which means I would get 2 imaginary solutions. In other words, this rocket, because we only launched it at 14 feet per second, it never got to 200 feet. So we can tell that by figuring out what the discriminant is. Okay? So the discriminant just allows you to figure out what type of solutions you're going to get. All right, that's going to do it.